Hi children, how are you all? Hope that all of you have enjoyed your vacation. Now it is time to restart our journey with the syllabus. So today onwards we are going to start our 12th classes. Okay. So we can start our syllabus with the D block and F block elements. Okay. So in last year already we have studied the S block elements and the P block elements. In P block elements for two groups we have studied, that is 13th and 14th group. Okay. This year we are going to study the D block and F block elements. Do you know which elements of periodic table are known as D block and F block elements? The elements which is present from 3rd to 12th group, they are known as the D block elements. What will be the reason for that? It is because in these elements the last electron is entering into the d orbital. Okay, so these elements are known as D block elements, and there is other name for this D block elements, that is transition metals. They are known as transition metal because they are present in between the S block elements and the P block elements. S block elements are purely metals, that already we have studied, isn't it? And when we are coming to the P block elements, which is present at the right side of the periodic table, most of them are non-metals. So the elements which is present in between this S block and P block, they are showing a transition from metallic character to non-metallic character. That is why these elements present from 3rd group to 12th group, they are known as transition elements or transition metals. Okay, and what is this F block elements, or which elements are known as these F block elements? Have you seen two separate rows of elements present at the bottom of the periodic table? These two rows of elements, each row contains 14 elements, are known as F block elements. It is because the last electron are present in the, or the last electron is entering into the F subshell. In these elements, the last electron is entering into the F subshell. That is why these two rows of elements are known as F block elements. Okay. In this lesson, we are going to study more about this D block and F block elements. Okay. This is the picture of modern periodic table, which contains 7 horizontal rows which are known as periods and 18 vertical columns which are known as groups. The first horizontal row or first period contains only 2 elements, that is hydrogen and helium. Second row, that is second period, contains 8 elements. Like that, third row also contains 8 elements. Now look at the fourth row, which contains 10 elements from group 3 to 12. Like that, in 4th, 5th, 6th and 7th period, there are some elements present in 3rd to 12th group. These elements are known as D block elements, or they are known as transition metals. So, the elements present from 3rd to 12th group in 4th period, 5th period, 6th period and 7th period, they are known as the D block elements. Okay. So, there are 4 rows of elements which are present from 3rd group to 12th group. They are known as the D block elements. Okay. Now, the first row of a transition element is present in the 4th period, that is from scandium to zinc. And second row of transition element is present in the 5th period, that is yttrium to cadmium. Okay. Now, the third row of D block element, that is present in the 6th period, from lanthanum to mercury. Now, the fourth row of D block element is present in the 7th period, from actinium to copernicium. Okay, so these elements are known as the D block elements. Now, we are going to deal with the electronic configuration, occurrence and general characteristic of transition elements with a special emphasis on the trends in the properties of first row of transition metals. Okay. Now, the first series of transition element, that is from scandium to zinc, they are known as the 3D series, because in these elements the last electron is entering into the 3D subshell. Like that, the next series of elements, yttrium to cadmium, they are known as the 4D series, because in these elements the last electron is present in the 4D subshell. Then in the next row of elements, the last electron is entering into the 5D, and in the next one, their electron is entering into the 6D. So, these rows of elements are known as 5D series and 6D series. First, we can study the names of first row of transition metals, that is the elements of 3D series. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. These are the elements present in the 3D series or first row of transition metals. This shows the atomic number, symbol, electronic configuration of first row of transition metals. Here the first element is scandium, whose symbol is Sc with atomic number 21. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. Here fourth shell is the last shell or valence shell, which is also known as the ultimate shell. And it is being filled first before filling the 3D subshell. So we can tell that the last electron is present in the 3D subshell. Okay. And that subshell which is present before the ultimate shell is known as the penultimate shell. So we can tell that the last electron is present in the D subshell of the penultimate shell. Okay. That we can represent like this. The last shell is known as the ultimate shell or valence shell, and the second last shell is known as the penultimate shell, and the third last shell is known as the anti-penultimate shell. Okay, like that in the following elements also the last electron is present in the 3D subshell. Okay. Titanium 3d2, 4s2, vanadium 3d3, 4s2, like that it goes. Okay. In the case of this first row transition metal, the last electron is present in the D subshell of the penultimate shell, that is third shell, or the last electron is present in the 3D subshell. Okay, that is why this row of elements are known as 3D series. Is it clear? Now, in the case of chromium with atomic number 24 and copper with atomic number 29, there are some slight changes. Here only there is a slight energy difference between 3D subshell and 4s subshell. So the electrons can jump from 3D to 4s, like that 4s to 3D. In the case of chromium and copper, one electron from the 4s subshell is jumping into the 3D subshell, which give rise to the half filled and completely filled 3D subshell, which are found to be very stable. As a result, these two elements are not having the expected configuration, but they are having the configuration 3d5 4s1 and 3d10 4s1. Now, how can we write the general electronic configuration of these elements? In all these elements, the last shell, that is 4s subshell, contains either 1 or 2 electrons. So we can write 4s 1 to 2. And the penultimate shell, that is 3D subshell, which contains 1 to 10 electrons. So we can write 3D 1 to 10, 4s 1 to 2. And that can be generally represented as n minus 1, D 1 to 10, ns 1 to 2. Now, by observing this configuration, we can see that in all these elements, the last electron is entering into the 3D subshell, or the 3D subshell is being filled, or the 3D subshell is incomplete. So, we can tell that in transition elements, the penultimate D subshell will be incomplete. But here, in the case of zinc, the 3D subshell is completely filled, that is, it contains 10 electrons. So that zinc is not considered as the transition element, even though it is present along with the transition metals. Okay. Now, the electronic configuration of next series of elements, that is 4D series, we can represent like this. By observing this, we can see that in these elements, the last electron is entering into the 4D subshell. So this row of elements is known as 4D series. And their configuration can be written like this: 4D 1 to 10, 5s 1 to 2. And generally it can be represented like this: n minus 1, D 1 to 10, ns 1 to 2. Here also the last element, cadmium, contains completely filled 4D subshell, so it is also not regarded as the transition element. Just like this, the electronic configuration of 5D series can be written as 5D 1 to 10, 6s 1 to 2. Like that, for 6D series we can write 6D 1 to 10, 7s 1 to 2. Okay. Hope that it is clear for all of you. Only this much for today. Okay. Thank you.